All right, guys, we're going to be simplifying square roots, cube roots, fourth roots, fifth roots. So to start us off, I want to give you guys a list of the ones that you absolutely should know. I've noticed over the years that too many people don't know perfect squares, let alone perfect cubes, fourth and fifth roots. So I'm going to write down all of the ones that you should know. And these are, first of all, these ones you should definitely know by now. So I'll write that 1 squared is equal to 1. 2 squared. Perfect squares, you should know a lot of these. I'm going to take you up to 12. You should definitely know up to 12. All right, so those are your perfect squares. You should absolutely know those. No questions asked. You should know what the perfect squares are because that'll help you to find what the square roots are. All right, and then perfect cubes, I don't need you to know quite so many. 1 cubed, of course, is 1. 1 to any power is 1, so it's a super easy number to deal with. 2 cubed is 8. That's 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And 6 cubed is 216. Say as long as you know up through 6, you'll be fine there. Fourths, you don't need to know quite as many. So basically what we're doing, if you look here, like 4 times 1 more copy of 2 is 8. 9 times 1 more copy of 3 is 27. 16 times 1 more copy of 4 is 64. So for the fourths, we just multiply these by 1 more copy. So 1 to the fourth, so times 1 more copy of 1 is still 1. 2 to the fourth, so 8 times 1 more copy of 2 is 16. 3 to the fourth, 27 times 1 more copy of 3 is 81. 4 to the fourth is 256, and last one, 5 to the fourth, is 625. You notice these start to get very big very quickly, so we're going to stop at 5 for the perfect fourths, and then for the perfect fifths, we're actually just going to go up to 3. So now 1 to the fifth is still 1. 2 to the fifth is 32. And 3 to the fifth is 243. All right, so knowing all these, like you need to know every single one of these values. If it helps to kind of keep it out as a reference, that's fine, but you need to know all of those. So an nth root, you can take square roots, we've been doing that for a while, but taking cube roots, taking fourth roots is basically the inverse of taking any of these roots, all right, or raising anything to a power. So raising something to a third power, taking the third root would be the inverse of that, kind of a reverse process. All right, so we have here for any real numbers a and b and any positive integer n, if we know that a raised to the nth power gives you b. All right, so we can go off any of these relationships up here. Then a is an nth root of b. Okay, so if a to the nth is b, then a is an nth root of b. All right, so for example, let's take like this right here. 5 cubed equals 125. So we know that 5 to the third equals 125. We can kind of fit it in with that. Then 5 is a third root of 125. Okay, or we could use this. 3 to the fourth equals 81. So 3 is a fourth root of 81. You can fill any of these powers into these variables right here. All right, so here's just like some quick info about the real nth roots, because when you're taking an even root versus an odd root, things come out a little bit different. So if we've got even versus odd, so say you're taking an even root of a positive number, you're going to have one positive root and one negative root. So you do the whole positive and negative, the plus or minus thing, and you end up with two answers. If n is odd, you just have one positive root. That's it. You do not do plus or minus if you're taking an odd root, like a cubed root or a fifth root. You don't do the plus or minus there. Say that a is negative and n is even. You don't have any real roots. 0 real roots. You'll have some imaginary roots, but you won't have any real roots. If I've got a negative under the radical and I'm taking an odd root, I will have one negative root. And if I come up with 0, the nth root of 0 is just 0, whether I've got positive or negative numbers. So those are all my possibilities. Keep those in mind as I'm simplifying up some of these answers. So I'm going to simplify these perfect squares or perfect cubes or whatever it is I'm taking. So I'm going to simplify these up and show you a couple of patterns. Okay, so square roots for this first one. First of all, I know that I'm going to have a plus or minus just because I had it on the outside, and I can kind of split up each piece individually. So I know that the square root of 16 comes out to be 4. That's one of my perfect squares that I have on the previous page, so I can just leave it like that. And then x to the 8th is what multiplies by itself to give me x to the 8th. All right, so I know for a fact that x to the 8th, I can write it as x to the 4th times x to the 4th. So that's what multiplies that by itself to give me x to the 8th. So what that means is that the square root of x to the 8th is x to the 4th. Okay, one easy way to do that is I'm taking square roots, which means I want something to multiply by itself twice. So I want to split x to the 8th up into 2 even groups. So here's one really easy way to do that. I can take my power of 8 and divide it by 2 because I want to split it up into 2 even groups. So when I divide 8 by 2, I end up getting x to the 4th. So that is the square root of 16x to the 8th. I take the square root of 16 and then I cut x to the 8th in half because I'm trying to get 2 even groups. Okay, so similar thing here. Got a negative on the outside, and then q to the 3rd plus 5 is like one quantity, and it's being raised to the 4th power. Okay, so remember, I want to take that 4th power and split it up into 2 even groups, so my new power will be 4 divided by 2, and that just ends up being 2. Okay, this one's a little different because I've got a 5th root. So this, I want things to multiply by themselves 5 times. So I know that the 5th root of 243 is 3, because I've got this on the previous page. 3 to the 5th is 243, so that means the 5th root of 243 is 3. So I know I'm going to get a 3. And now keep the same idea that I had up here. With 8 to the 10th, I want something to multiply by itself 5 times to give me 8 to the 10th, which means I want to split 8 to the 10th into 5 even groups. So I can take my power of 10 and split it up into 5 even groups. Okay, same thing with my power of 15. I can split it up into 5 even groups. Okay, so I have 3. I now have a to the 2nd when that simplifies, and I have b to the 3rd when that simplifies. And you can raise everything back to the 5th power. I promise you'll end up right back here. If you did 3a squared b cubed times 3a squared b cubed 5 times, we would end up with this. Okay, so this little guy right here, that 5, this is called the index. And so whatever is right here, that's what I'm splitting into. I'm splitting 10 into 5 even groups. I'm splitting 15 into 5 even groups. Here, the index is technically 2. If you don't write it, that means the index is 2. So for a square root, the index is always 2, which is why I'm splitting this into 2 equal groups. Same thing with this one. Okay, square root of -4. When I have a negative under the square root, remember I have I as my answer. So the square root of 4 is 2. Square root of -1 is I. All right, now one little thing to add on here, when you find an even root of an even power and the result is an odd power, so it's a very specific situation. Even root of an even power and the result is an odd power, you have to throw an absolute value because you know that an even root of an even power should come out positive. So you just have to throw in the absolute values just to ensure that it will come out positive because even roots could come out negative, so we just need to be careful. So 6th root of t to the 6th. Remember, I've got 6 powers, and I'm trying to split them up into 6 equal pieces. Okay, so that just ends up being t to the 1st, but t to the 1st, 1 is an odd power, so I have to throw it in absolute values for my final answer. Okay, similar thing happens here. The cubed root of 243, oh, that is a typo on my part, I apologize. That should be a 5. That index should be 5 there. So the 5th root of 243 is 3. And then when I take x plus 2 to the 15th, and I want to split it up into 5 equal groups, 3, so I have x plus 2, 5 divided by 15 is 3. This one we don't have to put in absolute values because I'm not taking an odd root, I'm not taking an even root of an even power, I'm taking an odd root of an odd power, so this rule does not apply. Even though the result is an odd power, this rule does not apply. Okay, I think, yep, the next page starts the next video. Okay. Okay, so guys, in the second video, really quickly, I'm just going to show you how your calculators can approximate some of these roots. So you absolutely need a calculator for this. This is nothing that you could do in your head, even if you wanted to. So we've got this thing about satellites, and it's got a function that we're going to be working with, which is this function right here. So they tell you that d is the diameter of the hole created in a solar cell, and then k is the energy that the dust particle is traveling with. So K and D are 2 things that we're going to be working with. So for part A, they say estimate the diameter of a hole. So we, according to this, we are trying to find D. And then created by a particle traveling with 3.5 joules, so that is K. So they give us a value for K, we're trying to solve for D. So D equals, we've got 0.926 times the cube root of 3.5 plus 0.169. So I'm writing this all down. I'm going to let my calculator do all the hard work here. Okay, so let me show you. If you do just a calculator page, oops, the glare, there we go. If we do just a calculator page like this, if you type in 0.926, so that's the beginning, and then times, now here's where your square root and everything, these buttons are right here. I'll hold it right up to the screen. So can you see next to the 4, there's the square root in blue. And then n root x means you can type in cube root, 4th root, whatever you want. So for the cube root, I'm going to hit control first and then this button, the little arrow, and then I can type in 3 because I want to take the cube root, and then arrow on over into that box, I type in the 3.5. Once I'm out of that cube root, then I can type this, the plus 0.169. Okay, so I type that in, hit enter. And that is my approximate value. All right, so might as well just write down all of those decimal places. 1.5, let's go 575. We'll go 3 decimal places. And it says diameter in millimeters, so that would be 1.575 millimeters. All right, let's look at the second one. It says if a hole has diameter 2.5 millimeters, so that's a value for D, estimate the energy with which the particle that made the hole was traveling. So that's asking for K. They give us D this time and they want us to solve for K. So we're still going to use this formula. We're going to plug 2.5 in for D. Now it's K that we don't know. Okay, so we're going to try to get K by itself, so whatever we need to do, so start by subtraction. So I'm going to subtract this decimal value from both sides. Okay, so it cancels over here, and I'm just going to use my calculator for this. So 2.5 minus 0.169, and I can just type that in. I get 2.331. Make sure you keep all your decimals while we're in the intermediate phases of the problem. Okay, so we do that. Next thing we need to do to get K by itself is divide by this decimal right here, 0.926. Okay, so this cancels over here. I need to plug this into my calculator. So I can just hit divide, because remember, it remembers the 2.331. So I'm just dividing by 0.926, and I get 2.51728. Same thing, keep all those decimals. Cube root of k. So now we need to get this k out from the cube root. So what we do to cancel out the cube root is we cube both sides, because those are inverses of each other. So when I cube this, the cube root and the cube cancel each other out, just like a square root and a square would cancel each other out. So I need to cube this side as well. Okay, so last thing in my calculator, I'm going to do answer. So hit control and then the little negative sign and hit answer. And then next to the 4, if you hit this little caret key, gives you a little exponent, and I can type in the third power, and I get this, about 15.951. And remember, that would be in joules. Okay, so really those buttons on the left-hand side next to the 4 are the important buttons here.